Welcome back, Course 2. Mr. Belke here with Lesson 100, Estimating Square Roots and Irrational Numbers, found on page 693 in your books. Let's get started. So, recall that certain counting numbers are called perfect squares. For instance, that would be 1, 4, 9, 16, 25, 36, and so on. They're called perfect squares because the square root of these numbers are an integer. For instance, the square root of 9 is 3. The square root of 25 is 5. Okay? So that's why they're called perfect squares, because they have an integer. Now, what if we had something like the square root of 29? 29 is not a perfect square. But if we want to find approximately where it would go, what we can do is we can see where this would fit in amongst other perfect squares. And we can see that 29 fits between 25 and 36. And we know the square root of 25 is 5. And the square root of 36 is 6. So the square root of 29 is somewhere between 5 and 6. Okay? Now, if we want to get even closer to that, if we want to refine that even more, we can refine that by finding a decimal number or a fraction that's closer to the square root of 29. So, for instance, what if we said, we know it's between 5 and 6, so let's try 5.5. 5.5 times 5.5 is 30.25. Okay, that's a little too large. So let's try something else. Let's go with 5.4 times 5.4. Okay, now we're getting closer. That's 29.16 at 5.4. Equals 29.16. And we can keep refining that down. Maybe we do 5.45 times 5.45. And now we're getting a little bit too high. So let's do 5.35 times 5.35. Okay, now that's a little bit too low. So we can keep refining it and find exactly where it would be. Now, I could simply just do 29 and hit the square root of that, and it'll calculate that out. Now, if I take that number and square it, I get 29. Okay, square root of that is there. Now, we can see that this is just an estimate. It's not actually equal exactly to 29, and we can determine that by saying 5.385164 times 5.385164. When we multiply those together, 8 times 8 is 64. This can't end in 4. It's got to end in 0. So while these are pretty close, they're not exact. In fact, the square root of 29 is what we would call an irrational number. An irrational number is a number that can't be expressed as a ratio of two numbers. For instance, let's say I have 2/6. Okay, that can be expressed as a ratio of two numbers. 2 is to 6. Now, in actuality, that reduces down to 1/3, which would be 0.3 repeating, but 0.3 repeating is a rational number because it can be expressed as a ratio of two numbers. 1 is to 3. Okay? And another example of an irrational number would be pi. Because pi goes on forever, it does not repeat, and you can't express it as a ratio of two numbers. You can get close. You can do 22 divided by 7, but that's not exact. Okay? So that's what we're talking about when we're talking about rational and irrational numbers. Let's do one more example of trying to find two consecutive whole numbers that the square root of 200 would fit between. Okay, square root of 200. Now, I know the square root of 100, right? Square root of 100 is 10. Another perfect square, 11 times 11. 121. 12 times 12, 144. 13 times 13, 169. 14 times 14, 196. And 15 times 15 is 225. So 200 would fall between 196 and 225, so it falls between 14 and 15. Okay? And that's how you estimate square roots. As always, if you have any questions, feel free to call, text, or email. Or you can meet me online live tomorrow between 9 and 10 o'clock. Have a fantastic day.